This is a lesson for Chapter 7, Section 5, titled Using the Pythagorean Theorem. However, we're not on day number 1 anymore. We are on day number 2, so I'll fix that real quick. So day number 2. And so on day number 2, what we're going to be taking a look at is we're going to go back to the distance formula, and then we're going to use the distance formula and the converse as one problem. And so that's our goal here. And so we talked about the converse of the Pythagorean theorem, and we'll look at that again. But then we also talked about the distance formula. So let's take a look at the distance formula again. So if I was to plot these points, and this one's going to be a little bit tough because I have to get up to 9, so let's fix these points real quick. Try something a little bit different. These points look better because we can fit them on our graph. So if I go 2 spaces to the left, up 3, or down 3 spaces, I've got a point right there. And then over 5 spaces to the left and down or up 1 space. And again, I want to find the distance between these 2 points. So what we said to do is, if we've got 2 points in a graph, we could just make a coordinate plane. Or I'm sorry, a right triangle. From the coordinate plane, we can make that and plot the points. We can draw the right triangle and count the spaces. So I see this as 3 spaces. Well, how did I get that? Well, if we take a look at the horizontal distance is the x components right here. -2 and -5. See, if I did -5 take away -2, I add the opposite, you see how I get -3. But again, I'm not concerned with the negative sign. I just want the distance between. Distance is never negative, so we're going to take the absolute value, and that's how I'm getting 3 spaces. Same thing here. If I count the spaces, I have 1, 2, 3, 4 spaces, so I know it's 4. Well, how else can I get that? Well, if I look at the y components, these two right here, and I subtract -3 take away 1. And I take the absolute value of that answer because I just want the distance. That makes, I add the opposite, -4. And the absolute value of -4 is 4. And that's how I'm getting the 4 right there. That's another way to do it. So the distance formula is something we're going to use on this problem. That's why I wanted to reintroduce it to you again. So again, if you're taking the difference of the 2 x components, so x minus x1. In the book yesterday, it said x2 minus x1. It's the same thing. It doesn't matter as long as you just take the 2 x components and subtract them. And then you square the answer, and that's why it doesn't matter whether it's positive or negative. Because when you square it, it becomes positive. And so we go ahead and plug in those numbers into the distance formula. Again, we've already done this, -2 minus -5. I'll add the opposite again, and then I'll square that answer. So underneath the radical sign, we're going to end up seeing a 3 squared. That's what I get when I do -2 plus 5. And then for the y components, again, it was -3 take away 1. And I'll square that answer. And so I'm getting a -4 when I go ahead and do that subtraction. Because, again, I added the opposite. But it doesn't matter whether it's negative or positive, because when you square it, it becomes positive. So it's 9 plus 16. Well, 9 and 16, those add to make 25. So I see the difference between those 2 points, or the distance between those 2 points, is 5 units. So 5 units. And so we're going to use that concept to help us come up with this answer here. So let's take a look at it. So it says you design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend runs the play as shown. Did your friend make a 90-degree turn? Each unit on the grid represents 10 feet. Okay, so what we're going to do is we're going to make, you use the Pythagorean theorem twice, or the converse of the Pythagorean theorem. So use the distance formula to find the length of the 3 sides. So let's try to find D1 here. D1 is found by looking at these sides here, and it is a 3 by 3. That's the length of those sides, and so it's going to be distance equals 3 squared plus 3 squared. And again, if I didn't have the graph, I could just subtract. 30 minus 60 is okay, so that's going to be 30. So we've got, since every unit is 10 feet, let's go 30 squared. And let me fix that real quick. Easier this way. So 30 squared, and then plus 30 squared. And so again, I'm 30 squared because each unit is 10 feet. And so if you look at it, 30 minus 60, that makes 30. 20 minus 50, that makes 30. And that's, even though they're both negative, when you square them, they become positive. So this ends up being the square root of 900 plus 900, which is the square root of 1800. Okay, we're going to leave it just as an answer like this without taking the square root. And then we're going to look at the distance number 2. And so distance number 2 is this one right here. So I'm going to count the spaces. Again, I can count the spaces, or you could do the subtraction, whatever is easier. See, it's 30 minus 80. You could probably do that faster than you could count them. So we'll do that this time here. Rather than counting the spaces, 1, 2, 3, 4, 5, I see that's 5 spaces. So I can subtract 30 minus 80, and that makes 50. And then I'm going to square that answer. So again, that's going to just be 50 squared, which ends up being 2,500. And then over here, I'm going to add on, and then again, I could subtract 20 minus negative 30. 20 minus negative 30. Again, you add the opposite, that makes 50. And so 50 squared makes another 2,500. And so when I add those two together, I get 5,000. And so now I'll look at distance number 3. So again, you could just draw the line up and draw the line over and count the spaces. 1, 2, 3, 4, 5, 6, 7, 8 spaces down, 2 spaces across. I see that. And so, or the other way is to just subtract the numbers. And so we'll do both. So I already counted the spaces, but let's do the subtraction as well. So we could do 60 minus 80. 60 minus 80 is 20. And so if I go ahead and square 20, 20 times 20 makes 400. Negative 20 times negative 20 also makes 400. And so that's how I'm getting that answer. And then over here, this makes 8. And so again, 8 spaces is 8 times 10 is 80, so I know it's 80, and so I know it's going to end up being 6,400 when I go ahead and square that. But if I didn't know that, I could just subtract these two numbers. 50 minus negative 30. 50 minus negative 30, I add the opposite, and you see 5 plus 3 makes 8. So it's 80. 80 squared is 6,400. And so when I go ahead and add those two together, I end up getting 6,800. All right, so now we've got those numbers. So now what we're going to use is the converse. So use the converse of the Pythagorean theorem. Okay, so the converse of the Pythagorean theorem says this. If I go ahead and take the distance number 1 and square it, plus the distance number 2 and square it, and that'll equal the distance number 3 squared. So let's go ahead and plug them in. So rather than taking the square root, we're going to leave it in terms of the square root symbol. And we're going to square these values. And so let's see what happens when we do this. So I'll plug these numbers in. Now what we have to do is take a look back at what we've seen in the past. So remember way back a few days ago, we ended up doing this. We ended up taking maybe like a square root of 16. And if I took the square root of 16, that makes 4, right? Well, let's say I take the square root of 16, but then I square the answer afterwards. And so I still have to do the work inside the parentheses first. So the square root of 16 is 4, but then when I square it, look what I get. I get right back at 16, the same number I had underneath the radical sign. So when you square a square root, the square root symbol cancels out, and you're just left with the radicand. And that's what we're going to be doing here. So we're squaring these values. And so when we do that, it's going to cancel out the radical sign. And we're just left with the radicand. And so 1,800 plus 5,000 plus 6,800, or equals 6,800. So let's see if it does. Yeah, these two numbers add to make 6,800. Well, since the numbers agree like this, we would say your friend did turn at a 90-degree angle because the side lengths satisfy the converse of the Pythagorean theorem. So there it is. Those are the types of problems you're going to see on tonight's homework. Good luck.